show promising trends regarding the consistency across the different modalities and also with these levodopa equivalent plasma levels. And now I'll hand over to Fani.
I'll discuss the ASR experiments that we did on the Dementia Bank database. Let me quickly introduce you the logistics of Dementia Bank database. We have 98 speakers from healthy controls, 194 speakers from dementia group, and so combined we have 291 speakers and 550 utterances from both the groups. The average the duration of healthy controls is roughly around 4 hours, and AD it's 5 hours, so totally it amounts to 9 hours of data. And as you could see, the mean duration is around 1 minute for across all the groups. So, and using Kaldi, we developed a DNN HMM system as a baseline for our ASR experiments. So the ASR is trained on both AD and controls. We did 10-fold cross-validation. So we have divided the folds according to the number of speakers. So 10% of the speakers appear in each fold for each dementia and controls group, and then we combine them to form a single group. And the results are averaged for all language model weights across in each fold. So if you look at the baseline system, this ASR is based on is trained on both the AD and control data. So we have decoded it on the separately on the AD data and on the control group, and we have observed higher word error rates for the dementia people compared to the controls group, and the best word error rate is around 45% for the control group, and the average is around 50% word error rate. And we did an experiment where we want to see if we train a recognizer on matched population, as in the training condition is same as the test condition, like a separate recognizer for both the dementia and healthy controls group. And we have observed that the matched population is actually worse than the training on both and testing it on each individual group. And this is because, this is something we did not expect, but this is because actually we have higher amount of data to train the recognizers on both the groups. So it's the advantage is because of the additional data that we have on training the language model and the acoustic model on both the on the recognizer. So we did one more experiment where we reduced the amount of data used to train the ASR using both Alzheimer's data and control data. We made it roughly equal to the amount of data that we have to train the matched population experiments, and the initial results suggest that we are on the right. I mean that the matched population result is better than the training it on both the control groups. And we have the results last night, but I could not include them. And looking forward, so we want to implement some of the multi-stream techniques that I learned in Hinik's lab, and to train 2 ASRs separately on matched population groups, and when an unknown test utterance occurs, we want to use some performance monitor measures to select it and match it to the right ASR. We are also doing some bottleneck experiments based on multitask training. So we'll include those in the report.